This is a video using the law of sines, but we're going to focus on what we call the ambiguous case. When we give you a triangle that has a side, one more side, and its angle. We've already showed you how to use it for an ASA or an angle-angle side. We're going to show you for the side-side angle. All right, this is taken from a textbook that I liked. It's a little bit difficult to understand. You probably introduced this in geometry. Sometimes when we give you some pieces of a triangle, the triangle might not actually be true. So what we have to do first is we have to find the height of the triangle. So this represents height, and then you're going to multiply side B times the sine of angle A. And there's going to be some things that will pop up. So, first thing, if we give you an angle that's acute, so less than 90 degrees, and your A is less than H, so side A, is smaller than H, no triangle will exist. Second piece, another triangle, angle that's acute, so here's your angle A. When we use that formula, if the side and the height of A equal each other, then you have one triangle. You can go ahead and use the law of sines like we already have done in our videos. All right, one more case we'll go on to now, acute. If your A is greater than your B, you'll again have one triangle and you use your law of sines. The one that I want to pop up next, I'm going to change the color to red. This is the challenging one. So here's your angle A, here's your side A, here's your side B. If your A is in between your height and your B, you're going to have two triangles. And that's what our video is going to focus on, is that type. All right, now let's head over to the obtuse. Obtuse means greater than 90 degrees. If your A is less than or equal to B, no triangle. If your A is obtuse again, greater than 90 degrees, and A is greater than B, then you have one triangle and you can use the law of sines. All right, let's move on to our example. Oh, we have to show you these scenarios first. So let's go ahead and find the height. I'm going to go ahead and make this a little bit smaller too so you can see it. All right. You don't necessarily need to write these down. I just want to talk through these for a minute. So first thing you want to notice is the angle is acute, so it's one of those first four. And here is your side A, and then your angle B. And we want to figure out which of these scenarios is true. Is it equal to H? We haven't found it yet. Is it greater than? No, it's not. But we're going to go ahead and find that height. So we're going to use a height formula, B times the sine of A. So plug in our B value is 12, our A value is 82 degrees. Let's find that value. So we'll use our calculator, 12 sine of 82, and we get H to be 11.88. Notice that your H is greater than A. Here's your A value, here's your H. H is greater than A, so you have no solution. So no triangle can exist given that information. All right, I'm just going to go ahead and erase that for now. Let's bring it down. Here's when you have one solution. So you again have another acute angle for A. You have side A. Let's go ahead and find H. So H equals B times the sine of A. B is 12, sine of 37 degrees. 12 times the sine of 37, our h equals 7.22. Now, first thing, our h isn't greater than, our h isn't equal to a. Our a is greater than or equal to b. That's true. So we know a is greater than or equal to b. Now let's just check this scenario right here. Is a smaller or greater than h, but less than b? So is that true? No. So we don't have two triangles. So, all right, so we have one triangle. We can go ahead and use the law of sines to find those missing pieces. All right, here is our last example here. Here's another acute angle. Here's your side A. We have to find the h first, so 31 is your B, the sine of 20 degrees. So 31 times the sine of 20 degrees. And you get h equal to 10.6. All right, so we go across. Is h greater than a? Nope. Are h and a equal? Nope. Is a greater than b? Nope. Now let's check this one right here. Is h less than a, less than b? So h is 10.6, a is 12, and b is 31. Yes, that's true. So what you have is two triangles. And I'm going to save the example to find those missing pieces on this next video.